Hey everybody and welcome back to my channel. My name is Avocari and today we're diving into an exciting cybersecurity challenge on TryHackMe. So whether you're a beginner or a seasoned pro, there is always something new to learn in the world of cybersecurity. So let's get started and tackle today's challenge. Profiles. No profile, no problem. So it's a category medium, so not the easiest but also not the hardest. And definitely not insane, which are actually kinda really tricky at some time. It says here it takes about 120 minutes. So I'm curious how long it will take. So now let's just jump in, join the room, and let's see what we are dealing with here. The incident response team has alerted you that there was some suspicious activity on one of the Linux database servers. A memory dump of the server was taken and provided to you for analysis. You advised the team that you are missing crucial information from the server, but it has already been taken offline. They just made your job a little bit harder, but not impossible. Okay, so it seems to be a scenario which is pretty close to reality. We had some incident on a server, they took the memory dump, and we now need to analyze it. I guess since it is called no profile, no problem, we're gonna need to create a volatility profile. But we're gonna look at this once we're there. So first of all, we download the task files. I already did this and I'm gonna change over to my terminal quickly here. Already created a folder. We got a evidence.zip file and inside of it we have the memory file. So we can just quickly look at it. It's a data file. The first thing I always do is to run strings on it. And you can see there's a lot going on. There's a lot coming out. We can look through some of it, but I guess there won't be much of interest inside of it. There's just a lot of, readable text, but also a lot of gibberish just in between. So strings just takes everything it can find and is printable and not human readable as well. So it just takes everything it can find. Doesn't make sense all the time, but you can read stuff and you can maybe deduce some things out of it. At this time, I'm just gonna quickly look over it if there is something I would recognize, but I guess there is not much right here. Maybe this is too much. Let's do it again and just wait until it stops the first time. Okay. Oh yeah, there's actually some interesting stuff right here. You can see 5.4.0 generic, a build. This looks to be a kernel version, actually. So let's note this down already. Kernel version. And also back here, we can see Ubuntu 9.4.0, Ubuntu 20.04.2. Oops, this was the wrong button. Maybe this is our OS version. This might look to be the case. Is there anything else we can see inside of here? There's just a lot of, random stuff. Some binaries. Samsung Electronics, Matsuba, Truba, Arbit.tw. No, I'm not clicking that link. Is there anything else we can find here? Probably not. This, no, we're not gonna look over that anymore. I think we already have the two parts that we maybe need in order to create a profile, but let's verify that quickly. Maybe there's something else inside of there and this was just a coincidence. So we're gonna look for Linux version inside of our strings. This might take some time while this is running. Okay, no, we get the first results. Yeah, Linux version, again, the same kernel, again, the same operating system. So I guess we're safe with that. Yeah. Okay, so for the analysis, we need volatility. Volatility is pretty straightforward to download and install. There is a great guide by Sean Whalen. I hope I don't butcher the name completely. He wrote it in 2021 for both Volatility 2 and 3. So just go ahead, follow the instructions. You need to install Python 2, which already reached its end of life. It was stated here. So Volatility 3 is better and it's faster, but it doesn't have all the plugins and features that Volatility 2 had. So I still recommend you to install Volatility 2. I'm gonna do everything here in Volatility 2 since I'm more used to it, and if I'm not used to it, I also have my Linux commands cheat sheet for Volatility right here. But yeah, we're gonna now need to create a Volatility profile first of all, because the Linux Ubuntu 2004 profile is not in the Volatility profile list, so we're gonna need to create that. We already identified our kernel. Okay, we did this. So let's go and follow this tutorial right here. First of all, we need to generate the profile for Volatility. So what we need to do here is clone the GitHub repository of the Volatility Foundation. You can see right here, we have everything inside of it. There's also the volatility.py executable, which I'm using later on. So we now go into the tools into Linux. So we change directory into Volatility Tools Linux. Let's see what's inside of here. We have a makefile and a module C. So let's quickly go into the makefile, and we see here a kernel version, which just takes our kernel version at the moment. I guess we need to change this one to the correct one. Yeah, and they also just provide us the set command to replace everything. This is perfect. So what we now need is our kernel version, the 5.4.0.166 generic. Let's quickly verify. Yeah, beautiful. It replaced it inside of here. You can see kernel version is now our generic version. So we're good here. Next up, we need to run a Docker container. So I've never done this before, but I'm curious what will happen now. So we're gonna create a Docker container. We're gonna mount our Volatility folder, and we're gonna run it in bash. We're gonna get a shell after it runs, and it also removes after running. So I already downloaded the Ubuntu 2004 Docker. Sorry, I need admin sudo rights for that root password. I already downloaded it. Hello. So it will start up immediately on your end. If you're downloading the first time and the Docker container is not cached, you might need to wait for a little bit of time. Okay, but now we're in our Docker container. So what else do we need now? We need to install some libraries. We're gonna quickly copy that in here, but we need to adapt them again to our kernel version. So we're gonna copy that, paste that in here, and also remove the low latency here in the end. Replace that. We need build essentials, dwarf dump, make, and zip. Okay, let's install them. While this is installing, let's look ahead and see what we need to do. We need to change directory into the Volatility folder. Then we need to create the dwarf file with the Volatility tool. So we just run make. Remember, this was the folder we were in before where we modified the make file. Then we need to create a zip archive of the result. So I guess this module.dwarf file is what we're going to get out of the make command right here. And we also include this system map. So we need to change that back here again to our kernel version. but everything else can stay the same. And I guess we're also going to rename the zip folder. So we're already on 80%. So it's just going to take 1 or 2 seconds and then we're done. And let's see if I remember everything correctly. And we can go on. So we need to change our director into volatility. See, we're right in here. Let's quickly verify that we already changed the make folder. Yeah, this is correct. The make file is correct. We have our kernel version in here. So what we now need to do is we're gonna go make. This takes just 1 second. It compiles everything, and there is now our module.dwarf file in here, which we didn't have earlier on. Okay, so now we need to zip in Ubuntu 2004.zip. We're gonna include the module.dwarf file, and then we're gonna also include the boot system map. Okay, we generated that. Is there anything else we need to do? No, we have the zip archive with the profile inside of it, so we can just exit out of the Docker container. Let's quickly verify. Okay, good. Our Ubuntu version is here. So now the last thing that we actually need to do is go back and copy it into our folder for the volatility. In my case, 2004 zip file, and it's under my home directory, local. I'm gonna remove that space here so I have tab completion. We're gonna go into library and Python 2.7, site packages, and volatility, plugins, overlay, Linux. Okay, we have copied inside of there, and now we can actually verify if our version is actually existing. So we're gonna run volatility.python with our file. We're gonna go out. We're gonna go vol.py with our Python file. So tag F for file. We're gonna define the file that we actually want, our linux.mem file. We're gonna go info, and let's see if it is inside of here. I'm gonna grab Ubuntu. Yes, right here it is. The Linux Ubuntu 24x64. Perfect. So now we can start going into the detective work, the analysis of the memory dump. And one of the first things I always do is we go over the list of the active processes. Let's see if there is actually anything inside of here. So we're gonna go Linux ps list. The second thing you could also do is go, and we actually need to define our profile, which we now remember. Profile equals to Linux. Because it said right here that the command does not support the profile Windows XP SP2 x86. This might take some time, so I'm gonna jump ahead until the results are here. Okay, the results now just came in. They were printed in here. Let's make this a little bit larger so it's easier to read and we can look through the processes. You can see when they started. This was last in 2023 at the beginning of November, quite early in the morning actually. Yeah, let's see if there anything stands out. K workers, no, this is all just normal stuff. I guess maybe the malware or whatever was on the system. Do we actually know what happened on the system? Anything? No, there was just suspicious activity on it. Okay. We have some no, I don't think there is anything just now jumping into the SSHD, so we might have some SSH connections. Maybe not. Okay, bash is running, INS mod is running. Okay, this is interesting. We could have a look at this later on, maybe as well. But I guess we're gonna first of all maybe look into something else that we could do. So we don't want to see anything else of the processors. We also don't want process information at the moment. So we could maybe try the malfind later on, see if we find some malware. But I guess another good idea right now is to try and recover the command history. So Linux bash. This will now list a history of commands which have been executed. You can see already in the header, we have a process ID, we have the name of the process, I guess, the time at which the command was executed, and the command itself. And I guess we're on the right track here, because if I recall correctly, the second question was, when was it approximately accessed? And here we have a date format. So maybe we're on the right track here. Let's see. Yeah. This already looks promising. We get results. Let's start from the bottom. They extracted the image. Okay, so this probably is where we extracted our memory dump. What else happened? They cleared the bash history. They cleared the bash history of probably the root user. Maybe, maybe not. I don't know. They got some file somewhere. Okay, they downloaded the file and compiled it. They also did it up here as root. Oh, and they messed up. So they already pasted the root password in here. The root password is exposed. So this is our first answer of this challenge. Next up, what time was the user database approximately accessed? So we need the format of this. I already saw the second command as collide3 users.db. So I guess this looks promising, and we're pretty straightforward onto our second correct answer, and we know when the user database file was last connected to and accessed. So next we need to find the hash of a malicious file. What I already found in here is this wget command. I'm gonna note this down here just quickly. We'll also have an interesting IP here. So I already like to make some notes on stuff I find when just looking through it. You can see they downloaded some shell, they compiled the shell and then removed the shell C file. So it's probably no longer in the root folder. But then later on, they downloaded it again and forgot to remove it. So maybe there are remnants of this file here. So what I now want to do is to look through and find the files. There was a function called enumerate something. Yeah, enumerate files. So we could list mount points, but the thing we want to do now is to enumerate through the files and look if we can find something. And what do we want to find? We want to find either shell. So we want to look for two things. We want to look for shell.c, and we also want to look for pkexec. Let's see if we can find something here. So while this is now running in the background, I'm gonna quickly look into my cheat sheet again if there is something else that we want to do here. So maybe we want to then extract the cached files if we find something. So let's remember Linux find file. I'm gonna make this a little bit larger for you to read as well. we're gonna try to extract the cached file, which either provides the path to the file or the inode. So we could use these things. Okay, did we already find something? No, we did not find something yet. I hope we're gonna find something with this. If not, then we have to take another approach. Maybe looking in here, is there anything else? We need to get the file, so we need to find it somewhere. And what is the IP address? Oh wait, we actually already know the IP address. This might be the IP address which is malicious. So let's note it is down here already. We didn't find anything. Did I make a mistake here? Or was I just... Oh, yeah, you obviously need to escape the OR in here, because now I looked for that string. We need to escape it in order for it to work correctly. So this was my bad. It just, yeah, searched through the whole thing and didn't find it because, yeah, I was stupid and didn't escape it. So let's run that once more again in the background. Maybe in the meantime, we could look over something else. We need to find an IP address and the port. Is there another command that we could use, maybe under the networking information? We could look at the active information, so maybe with netstat, and we could try to find something there. So let's remember that for later on. Ah, perfect. We already got some results. As is expected, under Paco user, we find everything we need. We find the pkexec file, and we also find our shell.c file. But I'm only interested in the pkexec file, so I'm gonna now export that one. Remember, we earlier looked at Linux find file. Linux find file. We need to, let's make this a little bit smaller so we can read it. We provide it with the inode. And we provide an output file. And this is called pkexec. So we're gonna output that and save it in our directory. I'm now gonna go over to my second terminal here, and I'm gonna wait until the export of the file worked. This might take a little bit of time depending on the size of the file. But once it is here, we can then try to inspect it. Okay, we have it. Yeah, beautiful. It is here. So let's see what's inside of that pkexec. This is an alpha executable, so we could reverse it. I don't know if it's part of the challenge. I'm gonna go quickly with strings into it to see if I find anything interesting here. Yeah, this is standard for an ELF file. Again, we have the same IP address here. We do something with a shell. I don't know, maybe on this IP address, or maybe we grant this IP address a shell. So this is maybe a backdoor. This might also be the case, but I'm not really sure. I don't think it's part of this challenge to reverse this binary, but what we need is the MD5 hash. So we're gonna go MD5 sum of our pkexec file. We're gonna copy that and paste that in here. So next up, we need the IP address and the port. If you remember what we just looked at earlier, there was Linux netstat, and we want to grab for our IP address. Let's see if we find something here. So it's gonna look over all the netstat logs and yeah, data remnants, which is inside of the memory file. Hopefully we find something for our IP address, which is looking suspicious. If not, then we're gonna have to dig deeper, but I think, yeah, I hope there's something here. Good, we find some TCP connections over SSH, and then on the port 1337, we have an established connection with our bash. So this is probably our file we just looked at, because remember right here also bin.sh. This looks really, really promising. So perfect. We also got the port here. So next up, we need to find another file. We need to look for the full path of the cron job file, and we also need its inode number. So for that, we're gonna go back to our enumerate file. I know it's the same stuff over and over again, but this is memory analysis. So we're gonna look for cron. This again will take some time. In the meantime, I'm gonna go ahead and look again at what is still required from us. Okay, so we need to find the full path of the cron job file, and then we need to export it and probably inspect it. So while this is looking, we can already prepare some other stuff. What do we need? We need to extract it again. So we need Linux find file again with our inode. So if this takes too long, I'm gonna skip ahead, and as soon as I say I need to skip ahead, the first results come in. So we have something on the run, cron d reboot, the PID, this is not of interest. The systemd units invocation, cron service is also not of interest. Var spool cron looks promising, but I guess we need the cron tab for our root user. So this would be this one. I'm gonna quickly also export it, and then we're gonna go into the TryHackMe results cron root, and we need to change the inode to the correct one. Yes. So right here we're gonna copy our spool cron tab. Then we need the inode number, which is this number right here. I'm gonna paste that in as well. And we have our next correct answer. So there's just one answer left, and that is what command is found inside the cron job file. Good, the export already worked. We have our cron root file right here, so we can go las cron root, and right here on the bottom we have what we actually want. We copy the bash rc from opt into root bash rc. So we inspected some files. This was a pretty cool room, I need to say. It is a good introduction into volatility. If you haven't worked with volatility before, I think this is a good room for you to get used to the tool, to analyze a memory dump, and it's also pretty close to reality, I would say. So you could encounter tasks like this as an incident responder while working for your company or some other company. I don't know. You could really stumble upon those kind of tasks out there, maybe also in CTF challenges. But I guess definitely on this one you learned a lot from inspecting files, downloading files, looking over connections which were made in the past from different services and to different IP addresses, and also identify a malicious actor and retrace his steps with the command history. I guess there are probably some Easter eggs, or maybe I hope there are some Easter eggs hidden inside of this memory dump. I haven't checked for them yet. Maybe I will do sometimes in the future. But for now, I'm happy with solving this challenge, getting back into hacking, and solving more TryHackMe challenges in the future. Thanks for watching. If you enjoyed this video, don't forget to give it a thumbs up and share it with your friends. Hit that subscribe button and ring the bell so you never miss an update. I would love to hear your thoughts on this video, so drop a comment down below and let me know of what you think or what you would like to see from me in the future. Take care, and I'll see you in the next video.